Right, so hello guys. This is the second live stream that I'll be doing, where we're basically just doing game development from scratch. In the last live stream that I did, we looked at doing brushes and getting those to work, and the end result was actually quite decent. I mean, we ended up with not this scene. 1 second. Yeah, we ended up with this, where we were able to get essentially spheres working, and more than that, ellipsoids. So it's not just, you know, perfect spheres. We can have whatever kind of shape we want. And so the next step really is to take this tool set that's been made and allow it to take input for different types of blocks. So let's say we want to make a hill, and that hill has, you know, ramps, edges, it has corners, things that you'd expect. So it's looking a little bit less blocky. It's a similar system to what games like Space Engineers use, with some slight differences. So the goal today is to kind of get these shapes in and then look into applying different materials. Now, I'm fully aware that this system will change over time. This is going to be one of the core feature sets that will be iterated on heavily, and I don't think we'll just be kind of done once and then that's it. After some thinking about it, like, I know that the UI for this, for example, will not just be able to use one brush type and then that be it. I think I'll have to do some hybrid brush types where, say, when using the sphere, we might want these ramp pieces, for example, and given the current setup that we have with these functions, obviously they only take in one material type and one shape type for an entire shape that is created. So that kind of won't be flexible enough in the future. But what I plan on doing is either adding more, essentially, to this, where we can put in some kind of custom shape list, which I'm not going to lie, I might think it might be quite complicated, or make it so there's like a toggle within these functions which applies some kind of smoothing algorithm to not just the shape that you're building out of these smaller blocks, but also to the adjacent ones that are maybe affected by your brush use. So let's say you're designing a hill. You don't want that hill to just be made out of circles and then not affect any of the local blocks. So you want those blocks nearby to be able to deform or change depending on what has happened to its neighbours. So eventually we're going to need some kind of updater, and depending on how far I get with this today, it might be something that I look into. I don't know if I'll actually make any progress on it. For now, it'll probably just be different shapes, and it will be a very primitive system initially, probably hard-coded. And then also a similar system for materials as well. Now, to give you a picture of the end goal for this system, it's supposed to be dynamic, so that we can have user-created content and that kind of thing. So similar to the Age of Empires 2 workshop, where you can bring in different terrain types or like maybe texture overlays and that kind of thing. And that's a big kind of core of this project, and making sure that it's fun and feasible as well. So I'm sure if I do get through the initial hard coding stuff quickly, I will look into doing more of an architectural design, so that in the future we can start building out some more dynamic loading tools, essentially for bringing in custom models and also maybe workshop support if it is on Steam. So first thing we're going to do is within our header we want some new function definitions for changing material types on any of the blocks basically. So we've already got the spawning function. So this takes the static mesh that we have provided to it, which is just this file path here, and then it sets it at a world location, but we want to take this one step further. So this will be returned from a function so that we never have to edit this particular function again. This should eventually always stay the same. And then also do the same for the object texture as well. And that will be like a different function call. So the two things that we'll need here are finding the file path. So we'll have to do a bit of research into what kind of things we can return as a function, because I don't think text here can be returned strictly as like a data type. I don't think it exists as a data type, because you see here it's a some kind of preprocessor macro or something like that, where it's a definition, so it's not an inbuilt variable. So for now what I'll do is I will call it, I believe it's F string. I believe that's the name. Maybe not F string. Try string. So a lot of today will be trial and error, like I'm not going to lie. A lot of this will be me messing around with data types. Unreal's quite new to me, so it will be difficult for me to initially kind of wrap my head around all of this and figure out how it works, but I'm hoping that by the end of today I've got more of an understanding of the different data types and variables that Unreal Engine uses and has implemented in its source code. So if we use this and we say, we'll call it retrieve model name. And in fact, no, actually I'm going to do it slightly differently. I've just decided that what I'm going to do instead is give it a function called set block model. And this way, if the implementation of any of the block setting changes itself, again, we're not having to edit this down the line. Some of this may change, but just that little bit of abstraction should hopefully protect it a little bit from future changes, and I only then have to edit something in one place rather than going through this function and going, oh right, we want to change the behavior. Now we have to change how, you know, this part works, and we have to change how this part works, and we have to maybe rearrange our code a little bit. Like, that's the kind of thing I want to avoid. So we'll have void set block model and void set block texture. So for now, set block model will take in XYZ parameters, so it knows where it is that it's supposed to be referencing. And then of course we want some kind of way to pass in an ID for what model type it is that we're selecting. So initially, I don't know if this will change in the future, we are sticking to these block types. There are are a few more that need to be added. I believe in total there's something close to 12. This steep block I'm not too sure about. It's something that the other Josh gave me, the designer. Like, if you've not heard me talk about him before, he's basically the person that will be dealing with all the designery stuff on this project and all of the art assets and that kind of thing. So this one I'm not sure about because it doesn't currently fit within the implementation that I'm going for, which is this half block style thing. So I wouldn't say we're scrapping this necessarily, but it won't make it into the initial implementation in its current form. Not until at least I've either done some thinking about how it's going to work, or maybe he's trimmed the model into 2 sections. That might be a viable option. That might work. So the first step is taking in an ID for these and then deciding which ones belong to which ID. So for now, I will just, I'll give it a short. Eventually I'll turn this into probably a new enumeration class. Like that. So we'll just say short block type. And then similar thing for the texture. Or at least, maybe it's not quite right to call it a texture, let's call it a material, because that's essentially what it is, and it might not just be a texture, you know, it might have more things like color values or maybe some blueprint setups and that kind of thing. So for now we'll just give it a short. We'll call that material type. And those are kind of placeholder. We'll probably come back and revisit those at some point. If we create a definition for this, go right down to the bottom. I kind of like to have it open on 2 windows as opposed to using the peek through, just so I've got a bit more room to work with. So down here, we want something similar to this existing implementation. So all of this is fine. This is fine up to this point. But what we want to do is remove this functionality here and replace it instead with a set block model function call, along with obviously the x, y, z values. And then we've got, and in fact we don't have a parameter in here either, so it's important that we need to update this function definition. But for now, I'll give it a fixed number once I've copied and pasted everything in. So down here we want it instead to have this bit of code. Now, going back up to here, obviously this doesn't have a problem, but we want to be able to pass through the material type instead, so kind of chaining together our functions and allowing external classes to kind of have some input on what material is used. So if we go back to our definition, it's up here somewhere, I believe. Spawn model instance. We obviously need to put that in the header file so that it knows what function signature it should be using. And now we can replace that temporary 1 that we had, just to get rid of the error message, with that. This will, however, break some other calls in the code, and that's something that should be a relatively simple fix in the change voxel function. Is we put it in one place rather than all of these calling that function directly, we've kind of abstracted it away just a little bit so that it doesn't kind of have to change voxel here. We've abstracted it away just a little bit so that we don't have to directly edit the function call every single time, because I knew ahead of time that we would need a material ID and a shape. So go to here, should be here, there we go. So now what we can do is put in the voxel shape parameter. And actually while we're doing this as well, I will also put in the material, so just so that I don't have to come back to it afterwards, and it's already done for us. So to put material ID in there as well. And of course now as well we also need to update this function because we've changed its signature in the header file. And that matches now. And the only thing that we really need to take care of is also creating the this function as well here. And now what that means we can do is call set block material immediately afterwards, provide it with x, y, z, the material ID, and we can worry now about the implementation of both of these, and all of our function calls and all of that kind of thing have kind of already been taken care of for us, and there's nothing else that we really need to worry about. So what we can do now, go down to where we've just created these two functions and kind of think about how we want to handle this. So ideally we'd have some kind of enumeration class on load, but for now I'm thinking we kind of just hard code it in just as a test. I know it's a lazy way to do it and it will be rewritten at some point, but just to prove that concept itself actually does something and that we are able to get different block shapes in there and we're able to use the brushes in a dynamic way, we will do it in this kind of temporary way for now, and then later on in the stream we'll probably like retroactively fix that kind of thing. Let's do like a standard kind of case 0. That's our basic thing. This is our, like, you know, what's the first thing that we want to happen, and obviously we've already got this function, so we might as well call it here. And then it's just a matter of basically copying and pasting this, changing the number that we've got, and you know, thinking about it, it's probably actually appropriate that we are hard coding this because these shapes, these base shapes, realistically aren't going to change. I don't think in the engine itself I will allow these to be changed by content creators, these kind of basic terrain shapes. The models might be, or rather maybe the materials might be able to be changed. That's kind of more of a I would suppose that's more of a user choice, because it doesn't then affect gameplay, it doesn't affect code, it doesn't affect anything to do with how the game is played. That can kind of strictly stay as it is for now. And thanks, Beth. Just reading chat. We'll get rid of these temporary models that we've just put in there. And the way Unreal kind of deals with loading and file paths is we are preloading kind of like a uStatic mesh object. That's what these are kind of considered as in Unreal itself. And to work out where it is that it saves these, or at least the path finding system that it uses for its own content, we can get the specific reference to that object from this button here. So this copy reference we can use and pull in and replace this text snippet here, thing that we've just copied. And this is all relative to the game engine itself, so it doesn't matter where the game engine is installed or where anything else is installed. We can just kind of put this in and the engine will take care of it for us. So kind of a bit of a tedious process, but now I'll do the same for these other ones. So we get the copy reference, bring up the code window again, paste it into this line here, and lastly do it for the last one, copy reference. There, so now this function should be able to take what we had before, but kind of free us up a little bit in that we can choose what model type we want now. The materials will be a little bit more complicated, because like I say, we might want those to be a bit more dynamic and selectable. So we can now, in theory, test this actually. And I'm curious to see what it will do, because I think most of them are set to block type 1. I believe all the function calls have been updated properly so that it should work. But instead of just generic cubes like we had last time, there we go. Yeah, it actually did work. I'm quite pleased with something like this when it does work for the first time, because being new to Unreal, like, sometimes stuff doesn't quite work how you'd expect it to. But the fact that this has done what it's supposed to is great. So it's changed the model on all of the brush calls that I've used so far. So obviously I kind of want to fix that. I want to revert them, all the calls that I've done for testing, back to what they should be. But I guess I could build a basic hill or a basic shape out of some primitive block types now and kind of see how that works and kind of thing. Another important thing as well that I've just realised is I'll need a rotation as a part of this, because obviously I can't just have, well, I could, but I'm not going to just have a new instance of this model for every orientation that it can have. It's important that that can kind of be dynamically set, and the designer then not have to worry about creating a new model type for something that's relatively simple. If we go back to our definitions again in the header file, just thinking here about how best to do this, and I think the short data type can contain quite a large range of numbers, like it's not tiny. I'll look it up quick. So it's a 16-bit field, so I can't remember the size of that off the top of my head, but it's large enough basically for what I'm planning on doing. So what we can do instead is say this block type number that we're passing in can not only just represent the model type that we're using, but it can also represent its rotation. So element 0 will always represent just a cube because none of its properties really change no matter what orientation it's in. But then for case 1, 2, 3, and 4, we'll want to load in this model but spun round in different ways, and that's something that I'll have to look into how to do. So we copy this. And then we'll also need it for upside down as well, so we need an additional 4. And thinking about it, this is getting quite messy, so I won't do it that way. Tempting to do it that way, but I'm not going to. So I'm just trying to come up with a way that might work. What I could do is do it based on ranges. So, but then that would also have its own problems as well. I guess this part of the stream is going to kind of be very heavily like trial and error. There's a lot of stuff that I could do with this. And right now I'm just trying to weigh up what would be the best possible way to do it without having to do tons and tons of work. So I'm thinking I maybe do it in kind of a mathsy way where maybe certain like divisions of a number represent certain rotations. So if it's like a multiple of 4, for example, it might represent one type of rotation. Then I don't think that would really work. I could use, I guess, the bits of a short to represent it. So have the first, say, first 4 bits representing maybe the shape. No, you know what? Just so I'm not like wasting loads of time, I am just going to do it the other way. I'll do it with an additional parameter. Might mean changing a few things around with like function calls and everything, but then at least when using it from a user point of view, in the sense that I will be using this from the UI, I don't have to mess around knowing exactly what all of my object references are. I can simply choose the block type separately, which will have its own separate ID, and then separately define a rotation. And there's no complicated maths involved in between interpreting that and sending it back and forward. So, short block rotation. Obviously I need to update the reference to this as well. So this is for the set block model, which is down here. Now this shouldn't have an issue. There we go. But what will have an issue is anything that calls this, which I believe is simply the spawn voxel model function. So yeah, this is a function call in here. We want to basically tell it, you know, it needs to be rotated by this amount or whatever. So that unfortunately means updating a lot of stuff, because I forgot about this when I was building all of my brush types. Like, that was kind of an oversight that I had, so this will have to be an additional parameter, I think, on all of those other components, but that should be fine. It shouldn't be an issue. So we'll just go to add in here block rotation, and up here we need block rotation, so that's fine, but then we need to update the definition of that. I believe it's at the top. So now that's done, we break a lot of other places in the code. We need to update every single function definition so that it has a reference to what rotation it should be. I'll simplify that to rotation just to kind of fit the convention that I've established in all of these functions. So it's going to be a bit of a tedious process, but it needs to be done. And hopefully, because this is my container class, once I've had to do some of these underlying changes and all of these function definitions are kind of set in stone to some extent, there shouldn't be any major overhauls of these function calls. And these should just kind of stay how they are, because my plan is, once this container's built, once the terrain controller's finished, then I'm no longer going to touch it if possible. There might be some things that I might have to update, like I said, with block smoothing and that kind of thing, and maybe adding some kind of automatic updater when applying terrain smoothing. I don't know if that will be a feature of the UI class or if that will be a function of the terrain class. That's something I've not quite worked out yet. It's still important, but it's not something that I need to decide on just yet. But either way, it shouldn't be too big of a deal, certain things. So obviously now I need to go through and put the same thing in here, which is a bit of a pain, but you know, has to be done. I'm hoping that once like all of this kind of thing is done, like these kind of more tedious basic features, like right now we're doing kind of low-level engine features. I'm hoping that once these things are out of the way and once they're finished, some of the more exciting things like the AI feature, which is going to be quite a big deal, will be a lot more kind of entertaining, not only to program but to watch as well. And obviously, if you want the condensed version of this, like I'm sure I'll have some kind of update or condensed kind of live stream highlights style video where you're not having to go through 3 hours of me rewriting function definitions. Right, so now that's done, we need to update, change voxel. I believe the definition for this hasn't been updated. So change voxel will need voxel rotation. And that is just so that basically we can just pass that into here. But now, of course, we introduce a whole other group of problems. We now have to pass through the thing that we've just put in the function definition and update all of the function calls for change voxel. See that now change voxel here will have issues once we've updated the header file reference. Right, so change voxel sorted out now. But there's this one last thing that we need to fix. So I'm sure once it's caught up, sometimes it takes a while. Yeah, we get all of these errors. And these obviously need to be fixed. Also, all these things up here need to be fixed as well, because now we're introducing an additional parameter into that. For now, we'll just do another placeholder 1. We have been so far. Put it in the commented out ones as well, just in case I decide to use them again. In hindsight, what I should probably do, and what I probably will do at some point, is package up this data about a voxel itself into some kind of container. So maybe doing a struct or something like that, and then converting over each function to be able to just access that struct's components. But we'll see how it goes. It might turn out that I don't actually have to make that many more changes to any of these now. This might be one of the few final ones that I have to do. Copy that as well, make it a bit faster. Slowly work my way down. Most frustrating bit sometimes about programming is you know exactly what it is that you need to do. It can be like the simplest thing in the world, and then it just takes forever to do anyway because you've got to update so many different areas. So change voxel circle. I think I forgot to put that in. There we go. Should be fine now. And then we need to copy that in there. Same here. There. Right, so I believe that's everything now, and we can actually focus on the implementation of this. So I guess the first thing to do is to actually find out how new static mesh rotations work. Like, it might not be possible to actually do to the block itself, and that might be a problem. That might require some kind of larger changes in the engine that's being built currently. Like, I might have to wrap the uStatic mesh component in some kind of object and then rotate that. So do some quick Googling and see if I can find anything on it. Okay, so Hmm. It seems to me like this person set up an F rotator data type, or a variable I should say. And then they've used a component called a function called set relative location and rotation. So I assume set static mesh has some kind of function, or the static mesh component has some kind of function that I can use to do rotations with. Yeah, here we go. So I can do add world rotation. So I assume what this is going to do is take in some kind of data type. That should just allow me to specify what I want it to be. So I'll look up the thing that it wants here, which is f_quat. Okay, so it takes in 3 parameters, which is just, I think, kind of your standard rotational component. So not sure if that's in degrees or what, but should be fairly straightforward. What we'll do is just define the temporary one, since we only need it in one place, and just give it the parameters that basically make sense. And I will put this, in fact, in a different function so that we can call it separately for each object, and we're not having to redefine the same behavior over and over again. So if I close that, give it the same definition as the thing we've been passing in, so it needs to be a short, and then we'll say call it rotation. Oh, we also need the x, y, z as well. We've got the thing declared. I'll just copy that code into there just so I don't lose it. Close that, save it. So now we can use this, hopefully, to get the results that we want, and we'll use, again, we'll use another switch statement to define, I think it's 8 different types of rotation. So use the rotation as the thing that we're checking. And we want a case for the 8 different rotation types that we'll have. So obviously we've got case 0, that's kind of like the default, if you will. Oops. We've got Right, so we've got the 8 different types. We've got whatever the default model is, then obviously then rotating it 90 degrees each time on the z-axis. But then also we've got it upside down as well if we want it that way around, because the way the voxels work at the moment is because they're not square, they can't kind of be freely rotated. So they can't like be vertical, for example, which is why there's only 8. So our default case should be simply 0, 0, 0. And then I'm not sure what this 4th parameter is, to be honest. Yes, I can leave it as 0. I'll do a quick search and see what the 4th parameter is for that. Yeah, I find the Unreal Engine documentation very frustrating to read. Like the way, I don't know if this is the same for other people as well, but the way it's organized just seems very awkward to kind of have to dig through. Especially after having come from Unity. Like Unity docs are kind of a breeze to use, and they kind of walk you through the use of each function definition or each class definition, and then link to other related resources. Whereas the UE4 docs just seem to have kind of like a list of, I wouldn't say useless data, but it is not very helpful at times. Like just listing the types of constructors that it has, but then not explaining the data types and what they do, or what the parameters do in each of those. And you really kind of have to do some digging and some looking into things to work out each of those. I mean, regardless, I guess we can leave this as 0 for now and see what results we get. So we'll also put that into here. And we'll give this 90. I don't know if it uses degrees, it might not do. But we can always test it. So then as a part of this, we need to call that function. Right, so now that should all be passed in. So if we obviously duplicate that for the different block types, we obviously don't want it to just work for the cube because that won't make any sense. And in fact, we don't need it for the cube because it won't have any ability to be rotated anyway. Right, so now that we've got all of those set up, I've just seen what you've said, Byron. I guess you could do that kind of thing. Like, I'm kind of new to how the data types in this work, so yeah, it might be decimal. It might be using oh, what are they called? I forget the name. I forget the name of all sorts of stuff. So right, we'll try this. We'll see how it works anyway. But to test it, we need to pull the right types of functions. Like we want to obviously have a few things to compare. So we do change single voxel, duplicate that a few times. We kind of have like a lineup. Like I'll comment out some of this other stuff. You don't really need that anymore. Like it's nice to have this stuff in just so we can see it, but it's not really necessary. I'll leave the circle in, so it's cool. And we'll put in radians. That's the one. Yeah, that's the word I was looking for. I'll put in. Confusing when it's all the same number. So that's the rotation. So yeah, we want to try one with no change and one with 1. And I'll try your suggestion of doing okay, so you said to do F rotator like that, and then converting that straight to Saturnian, which I guess would work, I think, if I'm doing it properly. Doesn't seem to like it though. I see, yeah. So Byron, have you used UE4 a lot then before? No, so it's just me like, you know, having a bit of a moment then. Fast Googler. Yeah, I guess that's a good thing, yeah. It's part of the reason why I wanted to do this on Twitch, and part of the kind of thing that I'm going for here is like having lots of people being able to contribute and like have their input, and like if I get stuck with something, obviously everyone else is just, you know, maybe doing their own research hopefully, and not only will I learn something from it, but hopefully everyone else will as well. That's kind of the goal anyway, to like just have everyone collaborating. Like I think it'd be a really nice thing to do. So yeah, we'll put the various ranges in. So we've got, I think, 270 as well, not 2,870 or whatever it was I just put in. So we've got the 3 basic cases, just to see if they actually work first. And then obviously change their position slightly as well. So 1 in position 2 there, 2, 2, and then that should put them next to each other, so at least we can see how it looks. Now let's compile the whole thing. So yeah, this might take some time. Oh no, surprisingly quick actually, which is unusual. Normally it takes forever. Right, so obviously that didn't quite work properly. So let's work out what it's doing. So it's rotating them on the wrong axis. I think maybe Z is going forward in this case rather than... Yeah, it's just spinning them around on the wrong axis. So I will go back down. I'm guessing then it would be the Y position that needs to change instead. We'll give that a go. Hopefully it'll actually properly recompile this time. Because sometimes it doesn't pick up variable changes, which I spoke about last time, and it's kind of frustrating. There we go. That seems a bit better. That's something closer to what we want, which is great. Yeah, that's looking fine actually. That's great. And if we do the same thing but for the underside, we also need to offset it slightly as well, just so that it's rotating around the origin point. But I think the origin on these is at the bottom. And I'll ask for a fixed one that's in the center. But for now, I can just provide... So when rotating this round, obviously the origin point, we don't want it to be in the wrong place. We don't want it to be down here. So instead what I'll do is I'll just offset it slightly at the same time. So I've already got a function to do that, I believe, anyway. So we'll get rid of that again. Copy those. And this time we want a 180 flip on the... I mean, I don't suppose it matters which one we do, but I think it's the x-axis. And then again, we repeat the kind of 90, 180, sorry, no, 0, 90, 180, 270. There we go. Then we also need to provide the offset for that as well. So I had a function up here, did that, I think. Where was it? It would have been in the spawn voxel thing. So we used set world location. So I'll kind of want to do this, but use something that's relative instead. So I'll just copy that just so I've got kind of a reference to use. But I'm pretty sure there's something similar to that that's like relative. So instead of using that, we use search for position, or I guess location would make more sense. Here we go. So set relative location. Don't know why it's K2 on the function definition. Maybe it's some kind of special prefix. I'm not sure. Then use exactly the same format, but obviously with different parameters. So we're wanting to offset it not on the X and Y, but up by, I think it's 100. I would have thought it's just set relative location. I think, yeah, I don't know why K2 came up. It must be some special function for something else. But essentially that's all we want to do. And I'll test it just like... Well, actually, I'll put it in for all of them, so I think that should work anyway. And then copy all of these. Have one in position, have those on position 0 so that are one down, and then use 4, 5, 6, and 7 for the rotation values. Byron, yeah, translate probably would have worked as well. The thing is, with learning the ropes to this, like, I've come over from Unity. So some of the stuff is the same and some of it isn't. And a lot of this is kind of a bit overwhelming right now until like I find my feet with some of the functions and some of the ways that the different classes work. Like I will just kind of be hacking together solutions, and what I'll probably do is come back afterwards and kind of relook at some of this code. And like, you know, and I don't know if you program yourself, but you'll come back to old code and be like, oh, this is horrible, like don't know why I did it this way. I'm sure I'll do the same. Like when I come back to this afterwards, it'll look awful. So that obviously didn't work. Translated it in the wrong direction, I think there. So let's try going back down. Try negative. See what that does. You get paid to come back and fix other people's code. Just don't expect me to be paying you then. Alright, so at least I know it works. I can get rid of this comment now. No, if I could, you know, pay people, I'm sure I would, but at the moment I'm broke and I don't have any money, so yeah, you won't be seeing a penny from me, unfortunately. So it's doing the same thing again, which is odd. What I'll do is I'll try that thing that you suggested. I'll try translate instead. See if there's kind of some kind of translate function. I'm sure there will be. Nope. Just on the off chance there's like a move thing. Yeah, there's a move component. So hopefully I'll be able to get away with just putting in one variable. It won't require loads of complicated overloads, hopefully. Thanks for the reference, I'll have a look quick. Out of curiosity, do you happen to know what object this can be applied to? Like what type of object? Because this isn't a game object as such that I'm using here. The thing that I'm using currently is, I'll show you the data type. So it's a uStatic mesh component, which is not quite the thing that I think maybe this applies to. This probably applies to like objects themselves. It would be nice if it worked though. One thing I've just noticed that I actually set up for myself, which I'd completely forgotten about, is I'd actually put in these material and shape arrays so that I didn't have to do this kind of parameter parsing. And for whatever reason, at the start of this stream, I've just gone through and updated all of my definitions so that I pass down that information. But kind of, I mean, I guess it's still necessary because I still need to update this, but I'll change it around slightly so that I'm not doing as much work as I am currently. Yeah, I guess I'll try the I guess I'll try the rotation afterwards and see if that helps. What was it I was using before? So set relative. Oop, not that much. So set relative, swap them round. Try it for all of those. Should be a relatively fast compile, hopefully. Same thing again. I will try positive 100 now. The one thing I just find strange is that it's moving so much, because it shouldn't be separating itself. Oh no, that would make sense actually, yeah, because it's moving one block down from the rotation and then the offset of one down as well. No, that doesn't work either. So obviously that isn't quite the right function to use, or maybe I'm using it slightly wrong. Let's do some more Googling. Let's see if I can find anything worthwhile. So I think I found a forum problem that's similar to the thing that I'm running into now. No, that's not quite what I need. Am I moving it at full block's height or half block's height? That's a good point actually. I think I'm doing it at full block's height, so I can try that, I guess. I don't know if that would actually fix anything, but it might do. Or if it would give some kind of different result. I'm not sure. Because from what I can see, like, it's not even moving at all, even with the 100 block offset. So yeah, no, that's just not working at all. And I know I need to rotate it around the midpoint, but currently these basic like art assets that I've been given by the person I'm working with, they don't have the offset at the center yet. So I will request that he does that, just so that I'm not faffing around doing this kind of thing. It won't actually be necessary afterwards. So what I'll do is, for now, I'll get rid of this code, and then rather than making it a code issue, I'll ask Josh if he can edit it, and then I'm sure he'll be able to fix things around. And basically I'll just treat it as something where he can change the origin, and then this code will work after that. So it's kind of a frustrating problem though. Like, obviously it takes time to get new art assets, even if it's a simple change, and he's, I think, working at the moment, so that'll be something I'll just put on hold and deal with for now. But that means I can move on to the next thing, like knowing that the rotations actually do work. We can do materials, which is something I haven't done yet, so this will be interesting for me, swapping materials out. But I'm hoping it's relatively simple. I think the way it's done is actually the same as, well, not the same, but similar to this function here. Just where instead of setting the static mesh, we're setting the material for that object. So if I put that down there and comment it out, sorry, not brackets, I'm guessing there's some kind of set material. There we go. I'm pretty sure we can use this same load object function. Like, I'm almost certain we can. There should be no reason why not. So let me grab that, throw that in there. Needs another bracket on the end. And we want, I guess it's U material, I'm guessing. That would make the most sense. What's this saying? Okay, so set material maybe is like an indexed thing. Maybe it doesn't actually take the object itself. So again, we'll shift that down, comment it out, see what other functions we have access to. I'm not entirely sure what it would be. I would have thought set material would do the job. But obviously, I guess it's something where you kind of preload it and then index it and reference it through your index rather than loading it at runtime. I'll look into it quick. So if I search up UE4, I don't know, change material at runtime. Another issue that you get with trying to find things for Unreal specifically is that a lot of stuff is done in blueprints, which isn't ideal obviously when trying to program. So yeah, I think you're right, Byron. I think I can have multiple materials. I think the way it works is you kind of attach the material to the static mesh itself somehow. I'll look in the editor quick, poke around. So select an object to view details. Yeah, so it has these material slots. And I think that's what it's targeting. But I don't want that. I want to be able to do dynamic materials, like having something in, say, the Explorer, and then I guess wrapping it at runtime, but I don't know if that would work. I don't know if it supports that. Might not do. I know Unity does, but this is different. Like all this, the reason it's been so difficult for me transitioning over to Unreal specifically from Unity is that everything has to be pre-compiled in C++, which means basically any of the dynamic like material swaps or like spawning or anything like that I used to be able to do in Unity is handled kind of maybe not entirely differently, but so like enough to make a difference for me personally, such that like it's kind of complicated for me to wrap my head around initially, just because it's a different way of thinking and that kind of thing. And I don't know if I can enable or disable the material. I guess I could, but I'm thinking of performance here, because obviously there'll be a lot of these on screen. In the last stream I did, we had a few of the blocks rendered in, like we had the big ball rendered in and a plane rendered in, and the frame rate started to drop quite a lot in the editor. And I am going to optimize that, like so you're only seeing the surface level stuff, but yeah, still I don't think I want to be loading multiple materials into memory when it's not necessary, like per object. I think I'd rather have it just be on a kind of need to load basis so that I'm not hitting the RAM of someone's PC. Kind of an odd thing. So yeah, this is kind of it's a bit of a strange issue. Like, I wouldn't really know how to approach this in Unreal. If anyone's got any suggestions or has any resources that they know of, that would be helpful. So my guess is that there's some other function I can use that would use a different maybe data type or something like that. Allows them to be loaded dynamically. I'll see if there's anything else that pops out here. So okay, so that looks like it would. That kind of sounds like it makes sense. Like, that might be something I can use. Because it would be a dynamic instance of that material, I suppose. So I will look into that function quick. I believe it was set material what was it? Instance dynamic, I think. Okay, so they have a documentation page on instance materials, which hopefully will clean some things up or clear some things up for me. So, yeah, it's all in blueprints. It's really frustrating. Like, trying to learn how to do anything in C++ and Unreal is a nightmare. Okay, I'll mess around. I'll experiment and see what data types we've got going on here. And no laugh. Like, yeah, C++ can be hard to learn, but this isn't just like, if it was just C++, I'd be fine with it because I'm, for the most part, good with C++. It's all the Unreal related stuff that trips me up. So we've got, what was it again? It was like set material instance dynamic or something like that. I think it was near the top. Here again, this is using some kind of index. Maybe it's just telling it where to put it, potentially. Yeah, I don't want to use the first one. My guess is this would be the one I'd use, so new material interface. We'll try this. So the element index, so I'm going to want to index position 0 because I'm just kind of overwriting anything that's already there. And so this is the bit where I think I'm going to have to use this load object thing. My guess is that it won't work, but the least we can do is try. So I think no, I'll do a different Google search. I'll search up something like setting material from load object, because I'm sure that'll give me better results. It's hard to know exactly what to search for. Right, so this one's recommending using a U property, which, if you don't know what that is, it's kind of like the UI. It's like exposing those data types or those variables to the UI so that you can drag and drop certain content into the editor itself. But I don't want to do that because the base content that I'll be using will be changing over time, so that's not really an ideal solution. I guess I could. I really have no idea. I'm seeing this thing called U material interface pop up a little bit. So potentially, I guess I use U material interface to do that, and then God knows. For those of you who have joined, by the way, since I've started doing this problem, so I know there's a few of you, I'll just quickly show you what it is that we've been up to today, just so I can have a bit of a breather as well. So today I've been getting different shapes working, so just been able to pull different models in from the browser at the bottom there, which has been successful so far, and also being able to get different rotations in as well. So this is just using the single block brush, but then setting the rotation to something different. I believe it works for all the models now that are currently in the editor, with the exception of the steep block because it's not the right size. But yeah, the ball that we got working yesterday, obviously you can see that there working with a different shape type. And this will apply to all brush types that we've already made. So everything now has been updated to be able to accept these new block shapes. And currently I'm trying to work out this nightmare, which is getting materials to work at runtime, which is a difficult issue. Because from what I understand of Unreal, is it doesn't like to just use standard object-oriented principles when it comes to putting together new game objects, because it has its own garbage collection system and its own component management system and all of that kind of thing. So it's not as simple as just saying, you know, I want this data type of material and I want to make a new one, and then I want to put this material into this object. You instead have to use all of these like custom like constructor functions that they have. But unfortunately, like, it means not only do you have to find out what all of those constructor functions are, you also have to know how to use them properly, and a lot of them aren't always obvious, especially in C++. Like, if I can, I want to do as much of this as possible in code. I don't want to be using blueprints, and I know that may be is fighting against the engine a little bit at times, but it's how I work and it's how my workflow needs to be for some of the later features that I need to add. So AI will rely heavily on being able to directly manipulate certain things through code. And the more I can learn how to do in C++, the easier it should be over time in terms of development speeds, because then it's just a matter of like copying and pasting code snippets and I know exactly how they work. I don't need to hook anything up in a UI, I can just do it in the code editor, which is where I work primarily anyway. So yeah, so anyway, back to the problem. So there's a data type called UMaterial interface that I seem to see a lot, which seems to me is kind of similar to the equivalent of this block here in the UI. So I think if this was converted into code, I think this would be a UMaterial interface, and you plug materials into that, and then you load a UMaterial interface onto your static mesh, which is this thing that we've got here. I think that's how it works. I have no clue. So what we'll do is we will create I think the best thing to do is probably to create a you see, it's tough. I don't even know where to begin with this problem. Oh, hi Sam. How's it going? Yeah, I don't even know where to begin with this problem. I guess we can try making a UMaterial interface type. And then we'd say or maybe, in fact, sorry, I know I keep on backtracking on stuff like this, but I keep on reading different bits online and it makes me think it's maybe behaving differently to how I'm thinking it is. So instead of just using a UMaterial, we'll see if it can load as a UMaterial interface, potentially. So that doesn't seem to have an issue with it. So it's obviously a UMaterial interface type that we need. Just whether or not the thing that we're loading from the engine is of the type UMaterial interface, or if it's UMaterial. And then if that is the case, how do we convert between the two? So I'll try and make a new material if it's possible. I don't know if I have to do this externally, so I've not had to touch it yet. Yeah, so create new material, just call it temp. I guess it doesn't really matter. Let's see what we can do. I'm sure we can change some basic color properties or something like that. So I guess you drag it out. Yeah, color. No. Anyone in chat have any suggestions? I mean, I'll look it up if no, but Should I not just be able to edit that parameter? Coming from the perspective of a programmer, like using these materials is absolutely alien to me. So if anyone knows how to do this, then by all means, let me know. I would have thought it's like a color thing. Like if I guess I could choose that. No? Okay, that doesn't work. Right, I'll look it up. I'll look up how to change a material color. because surely it can't be that difficult. We look at bear with me. Because all I need to know is how to set the base color. Like I don't need to do anything complicated. So delete that. Give it, oh yeah, American spelling. So 3-color blend maybe. Potentially that. No. Oh god. In fact, I can just leave it as that for now, because if it doesn't have any color at all, it shouldn't matter. Like I should still be able to tell the difference. So so long as this exists, I should be fine. So I'll do the same thing that I did earlier, where I'm copying the reference directly off of the shape itself. And then obviously maximize this, we can see what we're doing. So with the reference copied, we want to plug it into here and see if that crashes. There's a good chance that this will crash because I don't think the conversion is correct, but we can always give it a go. So we've got the material type passed in. We don't need to worry about that for now, but we'll just do a switch statement like we did before. Recompile it, see if it gives us any errors first of all, because it probably won't if it's like file path based, which is irritating, but just how it is. Let's see if it crashes. Did I even call it? That's a good point. Did I even put it in the original function? Let's double check. So I was expecting a crash there and it didn't happen, so. Yeah, no it did. It did get called. So let's just double check what we're actually doing. Yeah, because that's strange to me. I would have expected it to, at the very least, show me that something was wrong. Unless these are identical. That might be the case. Let's give this a... I guess you just give it an... Is it an inch or a... It's a 3? No. This should be relatively simple stuff, and either I'm completely misunderstanding how this works or I don't get it. Nope. This should just be... Oh, there we go. Alright, I've got a colour, so... Yeah, let's put it there. So now at least, if there is anything changing, we should be able to see a little bit of a difference. Oh, and that's the secondary colour, so it's only the border that's actually changed. Maybe that's why I didn't see anything before. And in fact, before I do anything else, I'll update this one as well. Give it a nice, I don't know, give it a nice light blue, maybe. It's going to be a bit bright, these colours, but should be alright for now. Save that. Just quickly recompile everything just in case it does any changes when changing materials. I'm not sure if it does. No, so they still have the original colour from before. Obviously no change is actually taking place there. Whoops. Don't want to change the rendering mode. So yeah, this line here isn't actually doing anything right now. So my guess is we need to change it to index 2. So presumably it's creating a material at index point 2 and then setting that. We'll give that a go as well. Wait for it to be done. No, so it's still the same problem. Maybe there's an additional step. What we can try and do is copy that. So we use the same set material thing that I tried using before, but I tried using it incorrectly, and then set it to index 2. Does it like that? No? Needs additional stuff. It needs a U material interface. Okay, so maybe we can use this again. So plug that in. Comment that out. Why is it giving us an error? Ah. There we go. Go for a recompile. If this works, I'll be happy but frustrated at the same time. Nope. Looks like I'm going to kind of have to go back to the drawing board on this one. Do some more digging. I know it's not very exciting to watch when I'm just doing like research on the side, but I'll try and walk people through it, like if I find anything. So there's a whole video here on dynamic materials, and it seems to be quite a large tutorial, so I'll skip through it as fast as I can, and anything I find I'll tell you guys about. In this video is making a separate material, which is, I guess, yeah, is your starting point. I don't know if this is a C++ tutorial though. It might be, might not be. So thankfully he's using static mesh component as well. So at least I know that this person that I'm watching is using the same base code as I am. Although he is using U properties, which is a bit worrying. The thing is, all I need is that one component. I just need that one snippet of code that allow me to load something in. So this code is going through the entire process of setting up essentially what we've already done, like essentially just setting up components themselves. And in this tutorial is setting up like a trigger volume and everything like that. And I would show it if I could, but don't want to get like copyright striked or anything like that when I later upload this to YouTube. So again, still he's using trigger volumes, he's setting all of those up. Now that's probably something I'll have to learn how to do at some point, and I'll re-watch when it's appropriate. Alright, now it actually looks like they're doing something. Now they're making a uMaterial instance dynamic data type. So it seems like he's using he's converted it to a blueprint. That's really odd. Like, it just seems like he's done something completely. Basically, the thing that they're doing is completely not what I want to do. Does anyone have any like suggestions, maybe? I wouldn't be surprised though if you guys had fallen asleep at this point, because I feel like doing it. Oh, right, so I think I found maybe something that looks even remotely kind of like what I want. So, Fandangled, I'm trying to get in UE4, well, in C++ in UE4, trying to make it so that it can load a material from the content browser and apply it to one of the shapes at runtime. So I've experimented with these functions. So create and set material instance dynamic from material. That didn't quite work or do what I expected it to. Tried set material. Don't know if that's the right thing either. I'm trying to use this bit of code, which is how I loaded my block components. Like how you load stuff from the object interface, I guess. Well, that's not quite right either, so this is kind of frustrating. Okay, so this thing suggests making a UMaterial instance dynamic. It needs to be a pointer, and then I guess give it a name. Temp mat. And then I guess I can maybe use load object. That might work. Right, so I'm guessing this doesn't like the conversion. Yeah, so I'll turn that into UMaterial. So that's what it is. Is it like that? Yeah, I've seen UMaterial interfaces. Working out how they all kind of interact with each other. My guess is you can't just do that and then load it in, but we'll see. Yeah, it's a lot of info to take in. Hang on. So create dynamic blueprint background. So when you say blueprint background, do you mean like what do you mean? Do you mean in the material? Because what I'm using right now is pure C++. It's not using blueprints. Yeah, because you see that's using the blueprint implementation, which isn't what I'm doing. There is a way to do it in C++, because if you can do it in blueprints, you can do it in C++. It's just I need to find out how to get that to work. Okay, so there's this implementation which I've just found. So we create this data type, and then we say so we use the dynamic instance type. And then this is saying how you format the code, but obviously it won't. It really does not like the conversion. Incomplete class type. So even the solution that I've been given, well, solution that I'm reading from, isn't quite the thing that I want it to be. Alright, so I found another resource. This might be a bit more useful. Yeah, I found angled. I'm not sure if that's the issue. So in here I should be able to put the load object thing. Not even have to worry about this, I don't think. You seem to like that. No, you see, it doesn't like that conversion, so that's odd. Dynamic material. Maybe this is something that has to be set in the constructor. Give that a go. I'll put it somewhere temporary for now. And then change that to that. Yeah, Byron, I'm wondering if there is as well, but ultimately the goal is just to be able to load in materials from a file and then literally just change them on the fly. So the use case that we have is down the road, we want people to be able to upload their own like materials and stuff like that. So when like pushing them to the workshop, you should be able to then download them, and then in code, because it'll have to all be code based because it's run through Steam, there'll just be a material swap. So we're just taking whatever the default material is on the block and then having it just changed to something that's like indexed. So the entire material itself, so if someone wants to change the material completely, they're free to do so. Textures would probably be easier, but it wouldn't include things like reflection maps and everything else, which would offer more like kind of flexibility to the content creator, basically. Which is why it's important that we get material swapping in. Just like I'm looking at tutorials now, and maybe it's happening in the constructor, maybe that's why it's working. No, I mean the solution said that it should work as well, regardless of whether or not it's in the constructor. You see, when I first tried to do model loading, actually, I had a similar problem where I was just stuck for ages just trying to work out how Unreal handles object loading. Like, it really shouldn't be that difficult. It shouldn't be this hard to swap, like, to find a resource that tells you how to swap textures or materials or swap static meshes out. And I don't know why their documentation at the very least doesn't cover those fundamentals. Like, it seems pretty basic. So this is in the update function. So I'm sure there's an alternative that runs in update, but it has to be in update because this could happen at any time. Fandangled, like, what part are you referring to when you say create at load and then change later? Because the material itself can be done using this load object function, so that's fine. I've moved dynamic material declaration into the header file, so that's not being done at load. Sorry, at runtime. Yeah, create default sub-objects is basically the alternative to this function, but it's used for constructors. So this allows me to dynamically load an asset. I've used it elsewhere, like you can see up here, it's fine. Set a static mesh works like perfectly fine with that, which is why I find it so strange that setting the material isn't the exact same process. I did try that. I did try my mesh set material. I mean, I can give it a go again, I guess. We tried it down here. Is this will only set material only accepts a type of view material interface. So maybe I can do something like that and then use a constructor for it. So that potentially. That work? No, like it still has an issue with it. Even if I do Let's try load object again. But then obviously it's not the right conversion, so yeah, this is beyond me at this point. Yeah. So I guess I could try that. But then it doesn't like it. So I guess if I take this and do, I think I had to do something similar before. I did like, I know, but that's for sub-objects. That's not what I want, I don't think. I don't know, maybe it is actually. Let's try it. Create default sub-object. Give it map for now. Yeah, see, even that doesn't work. So that I'm not surprised at. Oh wait, hang on. Oh, now it's working. No? Oh no, the errors have come back. Okay. Yeah, that definitely doesn't work. Could try a dynamic cast, maybe. I don't see how that would fix the problem. I think the problem's elsewhere. Not be assigned to. Let's get rid of the dynamic part on that. Liking that a little bit more. I mean, the conversion works. Whether or not it crashes, I have no idea. But okay. And then we'll try putting variable directly into there instead. Okay, so that doesn't have any issues with that as such. I don't think it will work though. I mean, we can try it. Right, let's give that a go. We might actually have something now. There's no errors at least. Might not compile or do anything, but we can hope. No, it didn't. Hopefully I'll get some useful error messages though. So, cannot convert from T star to U material instance star. So again, it's not really that helpful. I have no idea what that means. Anyone got any suggestions? Anything else? Because Byron, like, I would try like dynamic casting and all that kind of thing, but for whatever reason, like the way, as far as I understand it, the way Unreal objects work just don't really support that kind of thing. Like they're not like traditional C++ objects, and it's really difficult to work with sometimes. I guess I'll give it a go on the off chance that it does work, but this hasn't so far. Then I have little hope for it, so we'll show the whole loading object thing. Yeah, dynamic cast won't work. I don't think there's any like definitions for it in the Unreal library. What I can do is I'll get rid of this because obviously it's not actually doing anything. Maybe I've just read something. Maybe I have to do. Nope. I'll do. Alright, so obviously we have to convert from uMaterial to uMaterial interface, so I'll try and find a way to do that. Uh, yeah, so Byron, from like what you were saying, like, yeah, it seems to be part of the inheritance hierarchy. Like, eMaterial instance seems to be, I don't know if it's the parent class or if it's like the subclass or what, but we need to find out how to convert one to the other, like maybe casting it somehow, but the traditional one doesn't seem to do anything, so. So I could try. Oh, this is annoying. Let's try something like this again. This is what was suggested by another forum post. And in theory, I think we can just copy and paste that in there. Oops. Undock. No, but again, it's complaining about incomplete types. So maybe if I put that in the I'll put that up here, maybe. No, it still has issue with it. Maybe this is an outdated way of doing it then. Maybe it just simply doesn't want to. Because this is exactly how a lot of the tutorials that I'm finding are saying how to do it, as far as I understand it, unless I'm misunderstanding a core part of how this works. Like, it surely would be fine to just set the material as a dynamic object, which it is. So Fandangle, I'm not creating it every frame as such, but the logic that calls this is not in the constructor. So it's not it's not something that can be done at compile time. It's something that has to be done after the fact because it's called externally. So, for example, on begin play, I'm calling all of these. Sorry if I didn't make that very clear, by the way. Like, I'm basically initializing individual objects, and then those objects can have a separate material type. And right now I'm just trying to get some kind of default material working or doing something. And no matter what I seem to do, it doesn't really want to work. Yeah, I've tried creating the material at begin play, but I don't really want to set it at each frame either. Like it wouldn't solve the problem really, as such. Yeah, don't worry, man. UE4's weird, especially the C++ side of it. I'll try to see if I can get the casting working again. It like that, maybe? But it's not throwing any errors, I guess. I think the important thing, Byron, from what you suggested before, is I think maybe I forgot to put the pointer on there. I think it has to be a type of U-material interface pointer, which is like a UE4 thing, so I'll give that a go, I guess. Not complaining at me just yet. So we'll see. Well, it's compiled, at least. But it didn't die, but it's still not done what I expected to do. So God only knows what it's actually doing. I don't even know if it's calling that line of code. For all I know, it isn't, but it should be. Just double check I've got the right file path. No, I'm using the wrong one. So I'll grab copy reference. At least I got it to compile though. It might just be that I was using the wrong type. So we'll save that. Hopefully this works. Oh, there we go. It's doing something. We got it to do something. There we go. That's all I needed. That's all I needed, just to be able to change the material type on the position 0. Oh, I'm so glad that's done. I've been spending, I think, the last maybe hour at least, maybe more, trying to get that one line of code. It feels like an hour anyway. It probably hasn't been. There we go. Right, I'm happy now. I'm happy. I make some more progress, which is good. So that's fine. At least I have this bit of code in. Like, I do need to re-engineer a few things, but this is the core line of code, which now that it's working is pretty good. So, right. What to do now? I've spent so long working on that problem, I've kind of forgotten how to, like, what else I wanted to do today. So, got rotations working, got dynamic material loading working. So I guess it's a matter of cleaning everything up a little bit, really. But then the question is, like, what do I clean up? Or is there anything that I can improve in this? For now, anyway. At least the materials are changing colour, though. I'll test if I can get multiple colours working first, I guess. So this one, I can't remember what parameter it is again. That shape. Material, so it's the one before that. So if I leave that as default, and then I build in like a little switch or something. Obviously, I'll change it later when I'm building this out a bit more and got like dynamic materials and all that kind of thing. But so we'll take the material type. Just the why is that not working? Material type. Okay, so now we can put this into case 1, and case 0 for now I will leave empty, just so that it's kind of like the default material on the objects. But obviously I can import more materials as of when they kind of come online through Josh, the designer. So let's see, so now I should have a mix. So yeah, I've got one block which I've got to the old material, and everything else is converted now. That actually looks kind of cool, not gonna lie, like the black with the purple. Looks kind of nice, but anyway, it works, that's the most important thing. So got brushes working, we have base materials being able to be changed, and the rotations. So now what I'm going to do, go through everything, refactor it. This might take a bit of planning, and you might have to bear with me while I'm going through, and some of it may be tedious, but for the most part it is just going to be kind of like restructuring things and trying to figure out what makes the most sense in terms of passing parameters. So if I have to refactor any of this later on, it's not a headache. So like this thing here will need changing slightly, because the way that or at least it will need adding to, because I've got a few extra variables now to take into account. I'm not even sure if I'm editing these anywhere. Oh, okay, so I am actually in the change voxel section. I'm not even sure if I call that actually. Let's see if I call. Yeah, I do. Okay, so that's the thing that calls the instantiate voxels. So yeah. All right, I'm with it now. So voxel, if I could spell, voxel data. And then we'll add an additional field. Called rotation. And then, actually we'll just copy that, it's easier. And then this will allow us basically to use it from a referencing standpoint. So we can't really use this to pass data into these functions, unfortunately, I don't think, because we don't know what they're going to be ahead of time. Like, we don't know what voxels we're targeting ahead of time. So it's not like I can say in each of these functions, you know, edit these attributes. I mean, I could, but it would be a long and tedious process. It's easier just to call this function and then have change voxel edit all of those for us. The thing that I'm now concerned with is I'm essentially passing in the same data repeatedly. Like each of my brush functions, I'm passing in the same data, so I'm thinking I wrap that up in some kind of struct, or like some kind of struct type, and then instantiate some instances of those when I call the functions, and then simply reference its parameters instead. Hey, how's it going, Stephen or Stefan? Right, yeah, one thing at a time. So if I do that, go to rotation, fill in the X, Y, Z, so we know what property we're targeting, what voxel we're targeting rather, and then obviously just put in the voxel rotation parameter into there. And now we can worry about cleaning up maybe some of these inputs a little bit. What I'll do is I'll declare a custom struct. Probably best if I do that outside of this so that I have access to it elsewhere. Yeah, I'll make a new scope, I guess. Just trying to think about what the best way to go about this is, really. Because obviously the thing that keeps on coming up repeatedly is we've got the XYZ, the material, the shape, and the rotation. Which obviously makes sense given those are the only properties that we've got to edit, but we keep on passing those down, and I don't think it's necessarily to declare them every time. If the amount of data that we need changes, I don't want to have to do what I had to do earlier and go through every single function definition and add on an additional parameter. Like that just took a long time. It wasn't exactly great, so maybe I can clean it up. Maybe it's not worth it. Yeah, because like certain brushes, they have variations, like they have the center rather than the actual position itself. Okay, yeah, you know what, I'll leave it. There's no point me getting too complex with it. The next feature to do. I mean, I'm not going to carry on with the stream for too much longer, but has anyone got any suggestions as to what they think I should do next for this? Like, is there any shape types or anything that maybe I've missed, or anything that stands out that I haven't quite done for today? If that's all I've got left to do, if I've already done the things I had left to do for today, I might call it there. Cones could be an interesting one, or like pyramids or something. But then again, like, would you really want that as a brush type? Like, using it from a designer point of view, like, would you want every shape under the sun? Like, would that be necessary? In theory, I could do all sorts. I could do I don't know. I could do things like I guess cylinders, like you say, cones. I could do pyramids, diamonds. Like, the sky's kind of the limit, so I might wait and see what people actually need. Can I deform with brushes? That's a good point, actually. So the way, so to explain how this is going to work, this brush system that I'm building currently, this isn't how it's going to interact with the UI. So this is simply a way to select a region, or to give it a region that you want selecting, or that you've already selected in the UI, I should say, and then change that to either be nothing, which would be air, or to change it to a certain material type. So when wanting to flatten stuff, I would build a tool within the UI which has the different shape types, which I've listed here, and then passes through to this class, or the object that's instantiated of this class, an instruction to say do one of these actions. And it could be that you want to input the air block, which is nothing. So that would be how you'd go about like deforming terrain. You'd use the same things but just put in a different material type, and then from there I can handle whether or not you want air or not. So thinking about it, actually, what I can do now is do the whole delete thing, because I already have a bit of code for deleting blocks, but I don't think it's used. Kind of, yeah. So like, your selection region is different from the actions that you complete on it. A bit like how you would do something like Photoshop or like GIMP, like that kind of thing, where you select regions, you select shapes, and then you perform an action on it. So they're like two separate stages, rather than it being like a free form brush thing. Although I'm sure that would be possible, but that would come in later on in the UI component. That wouldn't strictly be a part of this module which I'm building currently, which is just the raw data and some very primitive like manipulation tools, just for changing like individual things. And eventually these functions might even be moved out of here into the UI component. So right, what was it doing? So if I go to I'm kind of specifically interested in this. So if all I really want to do is a condition for saying if the material type in this space is not 0, then spawn something in. So it doesn't matter then what everything else is. So if voxel data.material is equal to 0, or rather it should be not equal to 0. So if it isn't air, spawn something in. So in this case, we're basically saying select the, so we're passing in like the region that we've selected via one of these function definitions, and then saying delete the visual component initially to get rid of the thing that's already there, to get rid of the old stuff. And then if it's not equal to 0, we want to spawn something in using the new material type. That should work. So to test that, what I'll do is I'll make the oh, that's an interesting point though. I need to shift this quick. Actually, no. Bear with me. So I just need to shift these along so that air has its own non-existent block type essentially, and it's not just the default cube. So case 0 just exists, doesn't do anything, but just so that we actually have access to these other shape types and we're not overwriting the default block as air essentially. And just reading chat again, like, yeah, with smoothing edges and stuff like that, I think the way that I'm going to handle that is you will be able to apply a, like, after the fact, like after you've used one of these brushes, if the material type that you are using is like deformable or it's like categorized as terrain, it will naturally smooth. So that is the feature that I'm kind of going to move towards after this, I think. But that will require a bit of thinking before I do that. So I think before I do tackle that problem, I'm going to have a day off or like have the morning off just to think about it and like kind of work out how I want to tackle that. Just so that in the live stream I'm not sat there for, I don't know, you know, I'm not sat there for half an hour just figuring out how exactly that's going to work. So I'll quickly implement this feature. I'll test it. So we've got our sphere. We want to cut through it, so we can use one of the other. In fact, we'll get rid of all this junk now. We don't need any of it. So we want to change a voxel ellipsoid. We give it a material of 1, so it's got the default block material, and then we'll use change voxel plane. And a plane in this case, because we're not defining a range, it's literally just all blocks on that single row, and we want it to be on the, I believe it's the XY plane. And then we want the height, so we're spawning our ellipsoid at height 30, so we'll do the same, so we'll cut it right through the middle. What material do we want? We want it to be 0, and then the other parameters are whatever, like it doesn't actually matter because there's not going to be anything there. And this should tell us whether or not the deletion works properly, because that was something I wasn't actually quite sure about before. I thought it works properly, but I'm not certain, like whether or not you can overwrite blocks in the correct place and whether or not what I've done actually releases the material properly. We do this. Yeah, there we go. It cuts through. So that's an example of how you do. Obviously not using a UI or anything like that, but that's an example of how you'd start doing like deletion and terrain deformation. You'd use the same like brush types, but negatively, essentially. So it's like, it's just additive and subtractive. Like all of the brush types that we've got so far can just be applied in the inverse way. So yeah, that's the kind of thing that would be happening, I suppose. Like I'll note quick as well, like it doesn't look like it's cutting it through the middle, but that's because the height of this sphere is even. So the center that we defined for it is actually offset by 1 up, just so that it like isn't in a weird place. So I guess on that note, I'll end like I did yesterday. I'm going to hang around a little bit for questions if anyone's like interested or wants to learn more about what's going on, or like what the schedule's going to be, or what's happening tomorrow, or whenever. And then I'll wrap it up. So let me know if you've got any questions, I suppose. I'm guessing not that many people are going to be like dying to ask anything, so we've not really done a lot today, but just anything. Right, well, I guess on that note then, before I leave, if you enjoy what I do and you want to carry on like watching this series and collaborating and all of that and kind of contributing to this and seeing where it goes, then please do follow, because like it's early days and it does help a lot, like growing the fan base. That's why I've put a little widget saying like let's grow the community, you know, so that we get kind of repeat viewers and all of that kind of thing. If you are interested, follow if you haven't already. And I guess I will be back. I think it's on Friday is the next one, so tomorrow, I believe. We double check. Yeah, so I'm scheduled for tomorrow. I don't know at what time I'll be able to do tomorrow yet, because I do have other plans. And if I don't end up doing tomorrow, I'll update the countdown and we'll do it Saturday instead. Alright, thanks for watching.